In this video we want to talk about some of the arithmetic tools that we encounter in business, and also to look at some basic simple bits of mathematics that would be useful sometimes when we're evaluating problems, again, in business. So as the slide here shows, we've got we want to talk about functional notation. We want to talk about the notation that we use when we're using numbers, the summation notation that crops up a lot in working in business, different types of average, mean, median, mode, frequency tables, and presentation. Now if we go slowly through this, if you're not very mathematically minded, it's still quite straightforward and quite easy, quite logical to follow. If at any time you're getting a bit confused, just stop the video, make some notes on it, and you can check it. There are lots of sources online, or simple mathematics books and statistics books can shed light on it as well. But I don't think there's very much to concern you in what we're about to do. So for a start, the functional notation. What we often use, I'm going to put the cursor onto the screen, we often use F for function. So we say demand is a function of price. F means depends on. Y depends on X. Y is a function of X. And we write it as Y is a function of X. Demand for petrol is a function of price. Demand for petrol depends on price. It's slightly more than depends on. It means that there is some sort of precise relationship between the two. In economics, people would say, well, as the price rises, less will be purchased. But it depends. All we're doing here is we're saying there is a relationship between those two, petrol and price, or between X and Y. Y is a function of X. One's related to the other. And we can identify two things here straight away with this little term over here. Y depends on X. Y is the dependent variable. Y gets its value from X. So whatever X is, Y is equal to that. So Y is depends on X. So this one here is independent, the independent variable. It's independent, doesn't depend on anything else. But Y depends on X. So it's the dependent variable. Now, the F here is called an implicit function. It's implicit because it tells us that Y depends on X, but it doesn't tell us how it's dependent on it. It just tells us it is. Y depends on X. It doesn't tell us how, what the relationship is. So we call it an implicit function. It does not tell us the precise relationship between the independent variable, Y, and the dependent variable, X. Now if we wrote f of x, function of x, is equal to 2x cubed plus 3x squared plus 9x minus 6, this is called an explicit function. Explicit because we know exactly what the function is. There's no secret. This one's out in the open. Up here, y depends on x. That's implicit. We don't know what the relationship is. Down here, we do know. We're told. So that's explicit. Now, if we know the value of x, we can evaluate a function. So let's say we're saying that f of x, some function of x, is equal to this lot. And we're also told that x equals 2. Now just put x equal 2 into here. So we have 2 times 2 cubed, x cubed, 2 cubed, because x is 2, plus 3x squared, plus 3, 2 squared, plus 9 times 2, minus 6. Carry on, carry on, carry on. So we get the function is 40. So we can evaluate it. If we're told the value of x, we can work out what the function is. Right. Take this example. The function of x is equal to that. That looks a mess. We're told x is equal to 3, find the value. Put 3 in. X squared, 3 squared. 9x, 9 times 3. 3x, 3 times 3. Just multiply it all out, evaluate it out, and it comes to 3.6. Straightforward. Nothing to worry us. Now let's talk about this summation function. We meet up with this at last. Summation means we add up. It's the sigma letter from the Greek alphabet. And we just simply add up the values. So if I've add up the values of n, and n takes the value 1 to 5, so we want the values 1 to 5, n. So in other words, n is equal to 1. And the summation is s here, sigma 1, 2. N becomes 2 on the second one. N becomes 3. N becomes 4. N becomes 5. And there are 5 of them. We're told up here there are 5. There's the 5. It's equal to 15. So the sum of the first 5 digits is 15. And we could write the sum of the first 5 digits as sigma n, where n is equal to 1 to 5. This one looks nasty. It goes b. b equals 1 to 3, 2b. Well, the 2's are constant, so that's easy. And b takes the value 1 plus 2 plus 3. It's equal to 12. So in fact, it's actually quite straightforward. Find the value of this one. Well, it's just the arithmetic is getting nastier. The concept is actually quite straightforward. C is equal to 1 to 4. So C equals 1 up to 4. Sigma 2C plus 2 equals. Now, insert what we know. We know C equals 1. So it's 2 times 1 plus 2. 2 times 1 plus 2. Plus 2 times 2 plus 2 plus 2 times 3 plus 2 plus 2 times 4 plus 2 equals 28. This one here, put x equal to 1, and we get this. 3 times 1 cubed plus 1 over 2 times 1. So it's 3 plus 1 over 2, which is 4 over 2, which is equal to 2. So all of that just equals 2. We could do the same down here. Just if x equals 3, what's the value? Put in the 3, and we'll work it down. What is the value of this summation? Well, n is equal to 1 to 3 of 4n. So it becomes 4 times 1, that's the first one, plus 4 times 2, that's the second one, plus 4 times 3, that's the third one. It stops at 3 because it tells us here we've got to stop at 3. Equal 24. This one here is particularly nasty. Evaluate that. Well, 2 to the power of n plus n. And it goes from n equals 2 to 3. So it starts at 2. So 2 n to the power of 2 is 2. So it's 2 squared plus 2. And then it goes 2 cubed plus 3, whatever that is. In fact, it's worked out here, 17. Okay, averages. Well, the arithmetic mean is the most popular one. You just add up the numbers and divide by the number of numbers you've got. So you've got 2, 4, we've got 5 here. So it's 2 plus 3 plus 4 plus 5 plus 6. 2 plus 3 plus 4 plus 5 plus 6. 5 and 6 is 11. 11 and 7 is 18 and 2 is 20. So it's 20 divided by 5, which is equal to 4. The average is 4. The mean is 4. Find the mean of that. You just simply write this down. Here there are 2, 4, 6 of them, so divide by 6, and it's 4 2/3. And in general, when you get a set of numbers, the arithmetic mean is normally written as x bar, and it's found as x plus 1 to 10 divided by n, or if you like, just add it up. We got the summation notation earlier, so it's 1 to n of xn divided by n. That's the general formula. You don't have to remember it, but it's, you know, that's what it looks like. Find the average of that. 2, 4, 5 numbers, down to 5 numbers, divide by 5, it's equal to 5. This one here has got minus signs, so you got 2, 4 of them. So you got that, plus minus 7, plus 7. The top, the numerator as we call it in fractions, the numerator is equal to 0. Well, 0 divided by 4, a quarter of nothing is still a nothing. So a quarter of 0 is 0. If you don't have anything and you get a quarter of it, you still have nothing. The median is the middle number. When we have, let's say, 5 numbers, an odd number here, it gets easy. First of all, you organize them in sequence. So we put down 2 first, then 5, 6, 7, 9. So organize them in order of magnitude. Then take the middle one. That's the median. 6. What's the median of the following numbers? Well, organize them. You got 6 numbers, so write them down there. Now, there isn't an obvious middle number. So what's the middle number? 1. There's 6, so 1, 2, 3. There's 1, 2, 3. So it's somewhere in the middle here. So you could take an average of 4 and 6, which will give you the 5. So the median is 5. It's in the middle. 3 numbers on either side. Five numbers there. It means that the median is easily found. It's 6. That's the middle number. Apply this formula, which will give it to us. N is the number of numbers. So you got 1, 2, 3, 4, 5. 5 numbers. So it becomes 5 plus 1. And a half of 5 plus 1 is 3. Now count. 1, 2, 3. So the median is 6. So this 3 here is the third number along. 1, 2, 3. Well, we can apply this, the same formula, so we can apply that. Now, have a look at another example. What's the median of 2, 6, 1, 7, 14 and 9? Write it down in order of magnitude. There. We have our formula. So we've got 1, 2, 3, 4. We've got 6 numbers. So it's 6 6 plus 1, which is 7. A half of 7 is 3.5. So you've got 1, 2, 3, 3.5. It's in there. And take an average, so it's about 6.5. There we go. 6.5. The mode. The mode is the most frequent number that crops up. And again, when you're getting a series of numbers, write them in order of magnitude. Rewrite them. Now here, the most frequent number is obvious, it's 2. 1, 2, 3, it's 4 of them. Whereas there's only 1, 3, 1, 4, 1, 5 and 1, 9. So 2 is the most frequent, that's the modal number. Now for a frequency table, well, go back to this one here again. Now if we write this down in terms of frequency, we'll just call this set of numbers x here. So we've got 2, 3, 4, 5 and 9. There's a 2, 3, 4, 5 and 9. Now for the 2, the 2 occurs 4 times. The frequency is 4 times. The 3 only appears once. The 4 appears once, 5 once and 6 once. Add those up, we get 8. 2, 4, 6, 8. There are 8 numbers and the frequency adds up to 8. So what we've done is we've made a frequency table. We've worked out that there are 4 2's. So we can represent that set of numbers as a frequency table. Here's a rather large, ugly set of numbers. Write them in order of magnitude, which I must have done somewhere. And when you do, you go 1, 2, 3, 6, 7, 9. And there are 3 1's apparently. 1, 2, 3. 2 2's. 1, 2. 2 2's. There. 2 3's. A 3 and a 3. There's 1 7. Yeah, just 1 there. So there's 1 7. So it's just a way of writing it down, writing down this set of numbers in terms of frequency. It tells us how many times each number appears. 6 appears 4 times. These can be represented, these frequency tables can be represented using computers or graph paper, and different types of graphs can be produced. Histograms are normal ones to show the frequency. A histogram would look something like that. It just taken that off Excel, the spreadsheet. But as you can see, different numbers can be shown. Excel, in fact, you can play lots of games with Excel. There are different types of graphs for different situations. Okay, so in this class we've looked at mean, median and mode. We've looked at the functional notation. We've looked at functions and getting a value for functions. And we've looked at frequency tables as well. And that just about concludes this session. Go back over the video. You can turn off the sound if you wish and just look at the slides and make your own notes and pad out your notes from parts of your own research into other material that we provide, and it's also widely available on the net. So in the meantime, that's it for now, so thank you for watching.